Hey guys, welcome back. This is our videos for sections 1.2.
So it turns out we can actually measure and construct line segments, and that's really, really easy. Let's take a look at an example. So here we have a line, and it's a number line, so we see points that are marked, so we can see locations of various things. Let's actually find the length of line segment WY. Well, how do I do that? Well, the length of that, let's just find it first of all. So WY is right here. And how do I find the length of that? Well, since I see the numbers on the number line, all I have to do is take the absolute value of the difference of those values. So that length is going to equal the absolute value of 3 minus 0. And what is that? Well, that equals 3. What about the length of line segment XW? Well, let's see where that is. Well, the line segment XW is right here. So what's the length of that line segment? Well, what we do is we take the absolute value of the difference of their locations. So in this case, I would take the absolute value of 3 minus negative 7. And how do I compute that? Well, when we have minus a negative 7, that's the same thing as adding 7. So I basically see 3 plus 7, which is 10, and the absolute value of that is 10. And so I see that the length of this line segment is 10, while the length of this line segment was, in fact, 3. So finding lengths of line segments, especially when they appear on a number line, is not a big deal. We just subtract the numbers that are associated with their endpoints and take an absolute value.
Okay, I wanted to talk about why we have to do absolute value. And it goes back to, like, if you subtract two numbers, you could very easily end up with a negative number. But if you're talking about the distance between 2 points, can distance be negative? Well, it can't. So even if I walk forward, that's a positive distance. If I take steps backwards, that's still a positive distance, even though you're moving backwards. So it's important that when you're doing distance between 2 points, to make sure that you end up with a positive solution.
You know, the great thing about geometry is that just using a straight edge and a compass, we can perform a lot of amazing geometrical constructions. Let me show you one right now. Let me actually copy this exact length, the length of PQ, that line segment, onto a different line. So what I do is, I just draw a line with my straight edge. I pick a point, let me call it A, on the line. Now I take my compass and I line it up so one end is actually going to be on Q and the other end just touches P. And if I sort of sweep through it, you can see I'm sweeping right through P. Now I pick up that compass and place the sharp end right on A and sweep through until I cross my line. And that point of intersection is the place I put my dot, and I call that point B. And this line segment, AB, has the exact same length as the line segment PQ. And watch, I can even show that to you exactly. Look at that. Isn't that cool? So just using a straight edge and a compass, we can go really far in geometry. All right, let's check out this question. So suppose that A, B, and C are collinear points. That means that all 3 points lie on the same straight line. And we're given that B is between A and C. And we're also given the following lengths, that AC, that length of that line segment is 25, and BC equals 7.2. And the question is, what is AB? So first thing I think we should do is just try to draw a picture of the situation. So we know that B is between A and C. So we have some line segment. And on one end we have A, and the other end we have C, and B is somewhere in between. I don't know where. I'll put it right over here. Now, what else do we know? Well, we know that the length of AC, so that entire line segment, equals 25. That's given. And it's also given that the length of the line segment BC is 7.2. So I'll write that as BC has length 7.2. Now, the question is, what is the length of the line segment AB? Well, now we're going to use this great postulate that says that if you want to find the length of the line AB, if you know that length, and add it to the length BC, then in fact that's always going to yield the total length AC when all the points reside on the same line. So, armed with that result,
notice over here on the right hand side, when he's working his steps out, he's listing reasons as to why he's doing what he's doing. And the reason, this reason right here, this AB plus BC equals AC, is called your segment addition postulate. And you'll need to know that name. So make sure you get that down, that segment addition postulate. That's exactly what it says. You can add up segments to get a longer segment.
I can now insert all this data. So let's see. AB, that's the thing I want, so I just better keep that there. Plus BC. Well, BC we know has length 7.2, and that equals the length of the segment AC, which is 25. So now I want to solve for AB. How do I do that? Well, I want to undo the addition of the 7.2, so I subtract 7.2 from both sides to keep these balanced equation. And when I combined, I see 7.2 minus 7.2 is 0, so I'm just left with the length of the segment AB here. And then I have 25 minus 7.2, and I see 17.8. So the length of this segment right here, we just found to be 17.8. Neat. Okay, now let's take a look at another example where we can see this result being used in practice. So here's a line segment, PQ. And we'll notice there's a point R in between. And we know that this length right here, PR, is 19. And we know that RQ has length 6x minus 1, although we don't know what x is. However, that x also has the property that 9 times x represents the length of the entire segment PQ. Our mission is to figure out what is the length of the entire line segment PQ. How can we do it? Well, we can use the postulate we just talked about, namely that the whole is equal to the sum of its parts. So this length is actually equal to that length plus that length. If I use that, I can write down now an equation. This entire length, 9x, actually equals this length, 19, plus this length, 6x minus 1. Now I can clean up this equation a little teeny bit and write it as 9x equals 19 minus 1 is 18 plus 6x. Now what I'd like to do is solve for x. So the first thing I'll do is I will balance this equation but try to put the x all over here. So I'm going to subtract 6x from this side and 6x from this side. And when I do that, what do I see? Well, what I see here is here I have 9 x's and I subtract 6 x's, so I'm left with 3 x's. And here the 6x minus 6x cancels. I'm just left with the 18. If I now divide both sides by 3 to undo the multiplication of 3 in front of the x, what I see is x equals 6. Now you might say, hey, that's the answer. X equals 6 and we're done. But always make sure we understand what we're supposed to actually do. Our mission wasn't to find x, it was to find the length of PQ. The length of PQ is actually 9 times x, so the length PQ is equal to 9 times 6, which is 54. So that's the length we were trying to find, and we just used the x equals 6 to get us there. Fun. Okay, let's take a look at a real-world question that has some interesting geometrical aspects to it. So here's a map, and you can see that Here's where I work. Here's a gas station. This is a math party at a friend of mine's house. And then here's my house. And there's a whole bunch of things that we know. And this, by the way, is one line segment, and all these points are on that one line segment. These are all collinear. And what I know is, first of all, that my house to the party is 900 meters. That's pretty cool. And I also know that this gas station is located halfway between where the party is and where I work. If this is located in the midpoint, that means that this length is equal to that length. The midpoint of a line segment is the point that's right in the middle, so these two lengths will be the same. Okay, but there's something else that I know. I also know that the entire distance from where I work to where I live is 3 kilometers. And the question that I want to know is, how far is the gas station from my house? That's what I got to figure out. So how will I do this? There's so much information here, we have to parse it through carefully. Well, the first thing I want to figure out is, well, what is this length right here? Well, I'm going to use this property that, in fact, I know that this entire length is 3 kilometers, and I know this little piece right here is 900 meters. And so if I take this length and subtract that length, I'll get this length. And that actually is going to be a useful fact that's going to come in handy. So let's write that down. Now, these units are different, so I better convert them. And so I'm going to say right now that this actually is the same thing as 3,000 meters. Do you see how all the units have to be the same? So now what I see here is, using the property that this length plus that length equals the whole length, I see that 3,000 meters is going to equal the length of the line segment WM, that's this line segment, plus 900 meters. Well, now I can actually solve for WM by subtracting 900 on both sides of this equation. And what I see here is, well, on this side I just get WM, and these drop out, add to give 0. And see here I see simply 2,100. So this length right here is 2,100 meters. This point is the midpoint, which means that this length is actually half of this number. And so what's half of, or half times, 2,100? Well, that's going to equal 1,050. So this length right here is 1,050. I know that this length right here is 900, and so therefore the total length of GH, that line segment, is going to be the sum of this number and 900, or 1,950 meters. Neat. We were able to actually find the distance from the gas station to my house just using some basic principles of geometry.
Hey, you guys, this video is going to cut off before it's done, so just make sure you finish the problem. It goes through most of it.
Finally, I'd like to take a look at this little expression right here, and I want to figure out what, in fact, are the lengths of AB, BC, and AC. And the only thing we know is that B is the midpoint of the line segment AC. Well, if it's the midpoint, that means that this length is actually going to equal that length. And so, in fact, what I see here is that 5x minus 8, the quantity that represents that length of that segment, has to be the same as the quantity that represents this length, because this point is right in the middle. And so what do? Well, I'm going to solve this for x by subtracting 3 from both sides.
I'm skipping a lot of the algebra. I figure you guys have got that.
Oh, the question was, what are these lengths? So now we have to figure out the lengths. So if we figure out the lengths, what is the length AB? Well, what I do is take x equals 4 and plug it in. So I see 5 times 4 minus 8. Well, that's 20 minus 8, which equals 12. So this length is 12. Now we can check and see what the length of BC is, but we know it should be 12 unless we made a mistake, because B is the midpoint. But is it? 3 times 4 It is 12. So it looks really good to me. And finally, what's the length of AC? Well, we know it's